Right, so my name's Aaron Harper. I'm a software engineer at Duo Security, and today I'm going to talk about a node framework named NestJS. If it will go to the next slide. There we go. So what is NestJS? It's a holistic framework for a node backend. And the reason why I'm using the word holistic is I'm trying to contrast it with things like Express, which have traditionally been considered a framework. Express is kind of more of a library because it doesn't solve all of the problems that we needed to solve on the back end. And Nest is a framework that actually is a lot more out of the box and a lot more well-rounded than Express and sits on top of Express. It offers first-party integrations for commonly used technologies and libraries. So Nest offers a lot of first-party thin wrappers around existing libraries that you're used to. So for example, for request handling, by default it uses Express, but you can switch to Fastify if you like. For REST API documentation, it uses Swagger. If you want to use a database ORM, there's a few options. Supports GraphQL, WebSockets, various forms of microservices communication. And if you're using it in more of a microservices architecture like with Kubernetes and need to have some health checks, it offers Terminus. And you can mix and match any of these libraries or technologies that you want. So the key takeaway is that Nest does not reinvent the wheel. A lot of these problems have already been solved in a great way by a lot of libraries, so why recreate it and do it its own way? It just leans into things that already exist in the community. Some of its characteristics are that it uses TypeScript. It's inspired by Angular and Java Spring, but even though it's inspired by Angular, it doesn't matter what UI you use, what front-end framework you use. You can use React, Vue, whatever. It's just the syntax will be a lot more comfortable to you if you're used to Angular 2.0 and above. It makes heavy use of decorators, and I think it makes the code a lot more readable, and it also makes the code a lot more declarative. The majority of your logic will be in class methods, and it separates logic into components. The first being controllers, which are used for request or event handling. For example, for HTTP requests, it's what if you're already using Express, it's what you use for a request handler. Services, which are used for data storage and retrieval, like for example, database calls. And modules, which are primarily used for organization. So for example, if we have a user resource, which we'll have in this demo, you'd have a user controller for handling the routes for user. You'd have a user service for managing the data, and both of those would be inside of a user's module, which helps with organization, but also reusability of code. It also comes with the CLI, which can scaffold the new service. And you can create the components that we just talked about using the CLI. It expedites development. And it lowers the learning curve for new developers. So today we're going to build a REST API with request validation and data persistence. So for handling our REST routes, we want to use Express. For our API documentation, we're going to use Swagger. We can use a lot of different databases, but in this case I have Postgres running in the background. We're going to use that for persistence. And then when we want to interact with the database, we're going to use an ORM called TypeORM. What Nest is going to do is it's going to help simplify the plumbing between these libraries for our application. It's not really concerned with Postgres. That's something that I just have running in the background. So let's dive in. If you want to scaffold a new service, you would run nest new and then call it whatever you want. In this case, I don't want to make you sit through an npm install, so I'm just going to use an existing one. So to start our service, we'll run npm run start dev. And this is going to not only start the service, but start it up in watch mode so that whenever we change a file, it'll automatically restart the server. So now that it's starting, I can run a command like curl localhost 3000. By default, it's listening on port 3000, and I'm going to get the message hello world back, which is just showing that the server started up. It's as basic as a service you could have. So I'll cd into that directory, and we'll open up the code. So we're going to delete just a few of these scaffolding files that we're not going to really use. We just wanted to get to the bare essentials, something you might be used to if you use something like Create React App. So now our service doesn't really do anything at all. All we have is an app module that's empty. There's nothing inside there right now. But we'll first look at the main file, which is the entry file for your application. So it just does a few things. One is we need to generate our application object. And for that, we just use a built-in Nest factory. And we pass in something called the app module. That's that other file you saw. Every one of your servers will always have an app module. Think of it as your root module, because what's going to happen is as we add these modules for various resources, we're going to have a graph structure of all of these modules, and the root entry point of this graph structure will be our app module. So that's how Nest will be aware of everything that we have in our application. So after we generate our app object from that module, under the hood, we're using Express to listen on port 3000. So the first thing I want to do is I want to create a Swagger page. There won't be anything on it off the bat, but it's a good place to start when you're developing an API. So the first thing we want to do is create our Swagger options object. And for that, we'll need to import document builder from, we'll just go ahead and try it. We'll need to install a couple dependencies. So we're going to install Swagger UI Express and Nest Swagger. Swagger UI Express is a third-party library maintained by the Swagger team, and then the NestJS Swagger is Nest's simple integration for Swagger to kind of help obfuscate and hide a lot of the plumbing for Swagger to make things a lot more simple for us. So now that we have that, I can import the document builder. I'll instantiate it. And here's where I can set the title of the page. We can call it whatever we want. In this case, we're just going to call it data service. And then build. So now that we have our Swagger options, but you can see it doesn't have any cognizance of our application. We've just set a few settings for Swagger. So the next thing we need to do is we need to create the Swagger document, which will actually consider our application. So for that, we'll use, I'm going to cheat just a bit just to see syntax, create document. Import the module, create document. The first argument will be the application object that we generated, and the second argument is just going to be our Swagger options we had above. The last line is now we need to tell the application how to serve up this Swagger page. So we'll call the setup function. The first argument is a path, so this is going to be localhost 3000/API is where the page will be hosted. Our application object, and then our Swagger document. So if I save that and I come to the web and go to localhost 3000 API, you can see our Swagger page is up. There's nothing on there right now. We haven't created any REST routes, but we got that started right now. So the next thing we need to do is we said we want to have a user resource for this service. So again, we're going to use the Nest CLI, and we're going to generate a module for the users. It's created a file, the users file. You can see here, users module. Nothing in there right now, but it's also updated our app module. If we take a look at that, you can see that it's automatically imported our users module and added it to our app module. We didn't really have to worry about how to piece things together. We're just using the CLI to help us build this application. So the users module is not doing anything right now. The next thing we need to do is we need to have some routes for it. So in Nest, controllers are used for your routes for your application. We're going to delete the test file because we're not worrying about testing for this demo, but you should worry about it in the real world. In our controller, we don't have anything going on in here, but we can add a couple routes. So the first thing I want to do is I want to have an array of users. I'll store it in state on the class. And I want to be able to get my users. So we'll return this .users. Additionally, I want to be able to create a user, and then I'm going to use the body of the request, which will be the same thing as the new user information. And we'll just push it to our users and return it. So we've got a controller with methods, but Nest doesn't know what to do with these methods right now. We need to tell it that these are actually routes, and then we also need to tell it which HTTP method those routes correspond to. So if we're getting users, that's going to be a get route, so we would just simply use the get decorator. And then when we're creating a user, we're just going to use the post decorator. It's the post HTTP method. Now if I save that and come back to our web page, you can see both of our routes have now popped up on there. Our get users route, we can give that a try. Execute. And you can see it's just returning an empty array because we don't have anything stored right now. And if I take a look at my post route, you can see that we don't have a way of being able to specify the body right now, which is the whole point of a post route. We have to have the user data in the request body. So we'll have to do a couple things for that. One is we've got an argument in this function, and a function can have a variety of arguments. In this case, we want the body, so we have to tell Nest exactly what that is. For that, we use another decorator, this time the body decorator. And then we'll need to tell Nest what the shape of that should be. In this case, we use something called a data transfer object, or a DTO. That's a concept that has existed before Nest. All a data transfer object is a way to describe shape of data as it's transferred. So all that's going to be is just a simple class, user DTO. And just for the simplicity of this demo, we'll only give it one property. We'll say our users can have a name, and it's a string. Now if I save that, refresh the page, you can see that we can specify a body now. So if I say name is Angela, we have an example value of name Angela. I can take a look at the model, and I know that, oh, whenever I create a user, I need to have a name, and it's required, that's the star, and it should be a string.
Hey, Aaron, can you zoom in on that page just a little bit?
Is that good?
Yeah, thank you.
So that's great so far. But another thing, so now we've documented what the request shape should be, but we still have not documented what the response shape should be. You know, this part's great for our developers, but whenever they're using an API, they need to be able to know what the response shape is going to be as well. Well, we can just reuse that same data transfer object as before. For the get route, we're going to use the API OK response decorator. We'll have the type array of user DTOs because we're returning an array of users. And for our post route, because we're creating a resource, we use the API created response with type user DTO. If I refresh the page now, you can see that the same example we wrote before is now being used in the response shape for our post route. And if I take a look at our get route, you can see that the same response shape is being used, but now in an array over here. So one of the last missing pieces of this right now is we don't have any validation. You know, we're saying that it should be a string, but if I type a number and create that user, you can see that we've successfully created a user with a name of number123, and we don't want that to happen. We want to have request validation. So for that, we just need a couple more libraries. These are, again, our third-party libraries. It's a solution that's already been come up with, so Nest is just leveraging the community for this solution. So for that, we'll just need to do a couple things. One is we will import the isString decorator from the third-party class validator library, which is a great library to use even if you're not using Nest. It's a great library. Just add that on there. So now we've told Nest, okay, whenever you have a user DTO request coming in, make sure that the property name is a string. But the missing piece now is Nest doesn't know when to actually validate a request. You could have a complex request validation where maybe certain routes you want to validate in certain ways. Maybe you want to validate a controller, or maybe you just want to validate all incoming requests. In the case, for simplicity for this demo, that's what we're going to do. We want all incoming requests to be validated. So we'll come back to our entry file, and just with one line, app use global pipes. We're not going to go into what a pipe is, but all you have to know is that when a request hits our controller, a pipe, it goes through a pipe first. So when we validate a request, we want to do it before it reaches our controller, and that's what a pipe can do for us. So we pass in our use validation pipe, instantiate that there, and just with those 2 lines of code, if I now try to create the user123, I'm getting a 400 bad request. Not only am I getting that bad request, which is what we want, I'm also getting a very descriptive message about what exactly went wrong. It's telling me name must be a string. And so what I can do is on the UI, I can actually create very descriptive error messages for users so that they can know exactly what's wrong. It's not just going to say bad request, but it'll tell them specifically what's wrong. The last piece right here is, might be tough to see, but right now status code 400 is undocumented. If we reload the page, we now know that we can get a 400 response, but we haven't mentioned that in our documentation. That's not great for our developers. So the last thing we'll do here for our documentation is let them know that we can also receive an API bad request response, and we can give it a description of bad request. If I refresh the page, you can see 400 bad requests is now in our documentation. So I think we have everything we need now for our API. So now I want to tackle some of the architecture concerns in the back end. Our controller right now is violating its whole purpose. It should only be handling requests, but our controller right now is also concerned with data, both storing data in memory, which is also bad. We'll get to that, but that'll be a little bit later. But it's concerned with storing data, it's concerned with how to fetch the data, and it's concerned with how to create the data. We want to have that separation of concern. We want this controller to be agnostic of where the data is coming from. So what should be concerned with the data is a service. So we'll come back to our Nest CLI and we'll generate a service for our users. Just like before, it's generated a test file, which we'll get rid of, but it's created a user service. In our users module, it's automatically including that user service. We don't have to worry about the wiring of this service. It's already handled it for us. So now if I come to that service, just real quick, I'm going to use everything that we did in our controller. But we don't need to worry about the documentation because and the request routes, because request handling, because that's a concern of our controller, so we can delete all these decorators. Really simplify the service. It's going to receive the new user. Got that. So that's all we need in our service. But now I want to use that service in our controller. So for that, we're going to use a concept of dependency injection, which is a concept that has, again, existed for a long time before Nest. For that, we just need a constructor. We'll say we want to use our users service, and it's of type users service. So now we just have to return user service, get users. And here we'll just return this.users service create user, and we'll pass that new user in. So just to make sure, if I come back to my page and I create a new user, successfully created. So our service is now handling the data. So the next step is, if I take a look at my service, we're storing the information in memory, which is not good because every time this server will restart, we're going to lose all of our data. We want to persist it somehow. So for that, we're going to use one more library called TypeORM. So what we're installing is the official third-party library for TypeORM, maintained by the TypeORM team. PG is the library maintained by the Postgres team. Both of those libraries have existed before Nest. And then we're also installing the Nest TypeORM library, which is going to simplify the integration of those libraries into our application. This part's going to get a little bit more complicated, so if you start getting lost in the code, don't really be worried about the low-level, into-the-weeds stuff we're doing with TypeORM. Just be worried about kind of more of the high-level concepts. So just to really emphasize the fact that it's a little bit overly complicated sometimes, I'm going to copy a config file that I made before. Okay, so don't really worry about what's inside this config file. All it's doing is saying which type of database we have and how to connect to that database. So don't really worry about that. I'm going to literally do hand waving on that. So what we need to do is we need to be able to say, okay, we want to use TypeORM. How do we connect TypeORM and our server to our database that I have running in the background? So just like how we have a users module in our graph structure of modules, we also want to have TypeORM in our graph structure. So we're going to use the TypeORM module provided by the Nest team. And now it needs to know about the specific configuration for our application. So for that, I'll import the TypeORM, how do I spell that? Config from TypeORM config and pass that in. So now what Nest is doing is it's checking the database, it's able to make a connection, but it doesn't really know what we want to do yet. All it's doing is just making sure that it can connect. So the next step is actually using TypeORM. So we'll need two more concepts now. One is a repository, which again is another abstraction that has existed before Nest. All a repository is an abstraction for interacting with the database. We need some way to be able to get our resources out, maybe delete resources, and a repository is going to provide that for us. It's just going to be a class which extends repository from TypeORM, and we're going to use the decorator entity repository. So we're having an error right now, and the error is because we're not going to have one repository. We're going to have one repository for every one of our resources. In the background, what TypeORM is going to do is it's going to map this repository to a specific database table. So if we added maybe a message resource, or maybe we added user options or user configs, each one of them would have their own repository. So we can't just say we have a repository. We have to tell it exactly what that repository is representing and wiring up. So for that, we're going to add I promise this is the last concept that I'm going to add it here. This is an entity, which again is a concept that's existed before Nest. An entity is a way to describe the shape of our data in our database, but in a more object-oriented way that's very easy to deal with in JavaScript. So for that, we'll export a class user and extends base entity, the decorator entity. And just like before, our user only had one property, and it was a name. But what TypeORM is going to do is it's going to look at the class name of user. It's going to literally create a database table called user, and now it needs to create some columns, which will be the properties on here. The way that I tell it that name should be a column is I just use the column decorator. But in addition to that, we also need to have some sort of unique identifier. We could have two Angelas in our database, so we need to have an ID to be able to tell them apart. I don't want to have to worry about coming up with a unique ID. I want to leave that up to Postgres, so I can use a different decorator, primary generated column, and it's going to turn this into an index that's always unique in this table. So now that I have that entity, I'm going to just throw that into my repository, which will tell the repository what it's supposed to represent. Let's pass that in there, and that in there, and I save that, and then pray I don't have any errors. Nope. So actually now, I have Postgres open right here. If I want to take a look at my database tables I have in there, you can see that we have a user table. This wasn't already created. We just created that now just by using JavaScript and TypeORM. If I select everything from that user table, you can see we don't have any records in there because we haven't inserted any data yet, but you can see we have both our ID and name columns. So we've created a schema, we've created a table without ever having to worry about the implementation details of Postgres. And because of TypeORM, maybe we don't want to use Postgres in the future. Maybe we want to use Cassandra or Maria or some different database, and our code will stay the same, and TypeORM will handle generating the schemas and managing the database for us. So now that I know that works, the schemas have been generated, I want to use that now. To use that, I need to import it into, so import TypeORM module. We need to import it into our users module. And we just need to pass the user repository, I believe. So now, just like in our controller, we use dependency injection to get our service in. In our service, we're going to use dependency injection to get our repository in. So if I come over to my service, I can say constructor, private user repository is of type user repository. Now I can say, when I want to get my users, I'm no longer storing them in the memory. I want to get them out of the database. So I can call this user repository find, which will get all of the records out of the user table. And then when I want to create a new user, I'm going to instantiate our user entity, set user.name to the name that's in the body of the request, essentially. And then I'm going to return that user, but we want to save it to the database. So we'll just call user.save. Saving to the database is asynchronous, so we'll need to await that, which in turn makes this function asynchronous. So now if I save that, come back to our web page, I create a new user named Angela. Successfully created. It's automatically created a unique identifier for her. And over here, at the very top, I can get all my users. And I'm pulling Angela out of the database right there. I can create another user named Dwight. Hopefully you all get the Office reference. I've created Dwight with ID 2. It's automatically being handled by the database. And I'm able to pull it out. So right now we have a REST API with request validation, and we're storing all this data in a database. This is pretty much production ready. I mean, there's some tweaks you'd have to do, but this just shows in, I don't know, about 40 minutes or 35 minutes or whatever this was, we've actually covered a lot of ground and developed actually a pretty mature service. So, the summary I want to leave you with is Nest supports a variety of architectures. Here we built a REST API, but let's say you wanted to add GraphQL. We could add that or use it instead or create a new service with GraphQL. If we wanted to add WebSockets, we could add that. Let's say we're creating a chat app and we wanted to have users create messages in real time, we could do that. If we wanted to have full-blown microservices, different services with different responsibilities, all under Kubernetes, we could handle that, and a variety of other architectures. So that's why Nest actually calls itself an architecture solution, because it handles a lot of this plumbing for you and lets you worry about your business logic instead. It's easy to implement popular libraries because they're creating first-party wrappers around these libraries to make it very consistent with the way you interact with them. You're using classes and decorators all the time, very consistent. It has a very helpful CLI, and it's relatively easy to migrate if you're already using Express. You can take your Express, it actually exposes pretty much every aspect of Express if you wanted to, and you can use your existing middleware. You can take your request handlers and throw them down in a controller. And if you want to learn more about Nest, the official documentation is great. The Nest, if you're more of a visual learner, you want to watch a course, the NestJS 0 to Hero course on Udemy is great. And if you want to see the project that we worked on in this demo, I threw it up on GitHub. So that's all I have. Anybody has any questions, I can answer them? Yeah.
I don't know if I just missed it, but do you have to use TypeScript with Nest?
They're all TypeScript files, but you pretty much don't have to use it at all. I mean, just like normal TypeScript, it can handle vanilla JavaScript. So the dependency injection, you do have to use it. There's a couple spots where you do have to use TypeScript, but it's very rare you have to use it.
Okay.
Anybody else? Yeah.
Yeah, when did the user table show? Like, when did that migration happen? When you restarted the server?
Yeah. So every time
create that
it's
table?
watching, so every time I'm saving, it's.
So if you add new entities, it will create tables for them, like when the app starts.
Once I created this user entity.
Okay.
Actually, I think just created the user entity. I think actually that created the table.
Was it when you did like the CLI does it?
So actually what's happening, this is part of the hand waving. If you take a look at the TypeORM config, you can see there's an entities property
Okay.
here. And this is how we're telling it anywhere in our directory structure, if you have entity, this is a big gotcha by the way, you have to do JavaScript there because it's pulling it out of your dist file. You actually can't find it in the TypeScript. So if you put that there, any place in our project where we put an entity, it'll look at that. And I believe just creating one will create the table for it. All right, thanks everybody.
Thank you. And Leah, you can get it set up. I am curious, who here has used an ORM and liked it as opposed to just writing SQL? Okay, we've got 1, 2, 3. Okay.
It has its flaws, but
Yeah, I'm curious because I think that I've had very limited experience with ORM, but you can also kind of get trapped depending on how good the ORM is, right? Is there a way to sort of escape out of that and just write SQL when you're using NestJS?
So it would be more of a TypeORM thing, but there's also
Okay.
SQLize. I think SQLize is a way to escape out of it. You probably know better than I would.
I haven't used it. No,
Okay.
I learned on Python, but
Gotcha.
The good ORM allows you to escape out of it because you can get in some situations where there's a performance concern. So a good ORM will let you get out of it when you need to.
Cool.
Cool. Ready?
Go ahead.
Hey everyone, so I'm Leo Generali, and this is a talk. It's called 11 Ways to Solve One Problem. I learned a lot while I was making this talk. The biggest one, though, is that you should never go to a football game if it's going to be sunny. My face is extremely burnt right now, and I'm in an excruciating amount of pain. So I hope I'm doing a good job hiding it. I'm going to be talking about Eleventy.js, which is a JavaScript static site generator and that uses Node in the back end. It's self-described as a simpler static site generator, and I say that up front to kind of frame this entire talk. A little bit about me. I'm a web developer at The Knot Worldwide, which is the team behind both Wedding Wire and The Knot and a few other products you might have used if you're recently engaged or are married or having a baby or somewhere in that kind of lifestyle. Definitely not where I am in life. Over there, I primarily actually use Ruby on Rails and PHP and Symfony. And in my spare time, I really enjoy using JavaScript. It was the first language I kind of learned, dedicated some time to actually learning and kind of how I got my start working professionally. So I like to kind of keep track of all the fun little things that are going on in the JavaScript world, which there are a lot. It's always moving really quickly. When I'm not doing development, I like to run a lot. And that actually brings me to my next slide, which I had to include. I want to apologize ahead of time. This summer has been really, really hot, and some of you may have had the misfortune of seeing me run. I don't think I'll ever get the opportunity to talk to this many people from Ann Arbor again. So when I was running, I was probably shirtless and sweaty and gross. And if you were having a coffee and I ruined it, I'm sorry for that. That's my bad. But enough with that kind of stuff. Let's go through the quick agenda. I'm going to start out by giving a quick primer on static site generators. Then I'm going to talk about a little bit more about what Eleventy actually is and kind of the problems that it solves. And then I'm going to try to convince you that you should care about Eleventy, or at least give you a few reasons why you should, so that way when we talk about it later, you can be like, yeah, that was a sick talk, Leo. That was fun. Yeah, I care about Eleventy now. And then you could go back to not caring about it. I won't be offended. I am going to say mostly surface level. This is kind of a shorter talk, and I felt that going too deep into the weeds might do a disservice to yourselves. When Google exists, then you could go home and Google it afterwards. We're going to start out by doing a quick history lesson. A while ago, we were writing HTML by hand, right? That's how web development kind of started. You would get these HTML files, and you would handwrite all your HTML files, and then throw them up on a server, and that's how people would go to your websites. They would literally download them directly from the server and check them out. I think a really good example of that you can still go to this day is the Space Jam website, which exists. It is still active. If you go to it on your phone, it's going to work. It is definitely not responsive. And if you're like me and you're kind of, I turned on the robot. And if you're like me and you're kind of maybe a little nostalgic for that time of the internet, you will make modern websites that use dancing baby GIFs and are probably heinous to anyone who would use them, but it's kind of a fun thing to do. And there were lots of pros and cons to these sorts of handwritten websites, right? It was really fast and secure. You were only sending HTML files from the server to your user. They weren't downloading anything. They weren't downloading anything extra. They weren't talking to a server. It was fast to get up and running. You could just FTP it and then be on your way. But the problem is that it got repetitive really quickly. Let's say you had a footer in your website that you wanted to edit a bunch of times, and you would have to go through all your HTML files and kind of edit it that way. And we're humans, we make mistakes. You might forget to edit the footer at some place, and then your boss gets mad at you, and that's not good. So fast forward a few years, and we started leveraging servers and CMSs and dynamic backends. Really, I think PHP is a good example of this. That's kind of when these sorts of things sort of exploded. And now we had partials that you could use, and based off of the data that you have, you could bring it in, and depending on what sort of resource you want to be looking at, you're changing the web page a little bit. And then we moved on to WordPress, which kind of simplified this for our users. And this also had a lot of pros and cons, right? This was really quick and easy to update your data. You didn't have to go through 1,000 different HTML files to edit just the price of a t-shirt on your page. Now you could just do it through a CMS. The problem was that it was less secure, and because you're relying on the server to do the work instead of going back and forth, instead of just requesting an HTML file, there's some additional work that has to be done. The server has to do some of that heavy lifting. So the main takeaway, right, that I want you to get out of this is that there's two ways of kind of displaying this data. Either you can build it ahead of time, or you could build it dynamically. I think there's obviously we get way more into the weeds about this, but that is definitely out of the scope of this talk. So if you got a little angry at kind of my description of the internet in 30 seconds. Please don't beat me up later, please. So if I did a good job, you're probably thinking to yourself, like, is there this middle ground in between these two things? And thankfully there are. There's these things called static site generators, right? And static site generators take any sort of content. In this example, I'm using a markdown file. This is definitely a blog post that people have used before. And it'll take your content and then create HTML out of it. And you don't really have to worry about, kind of those repeating doc type HTML, HTML lang English. You don't have to worry about all that stuff depending on how you set it up. And your data doesn't only have to be Markdown. You can use JSON that's right on your disk. You can use a YAML file and kind of read repetitive data that way. You can actually interface with APIs and save your data through. You can interact with APIs and get your data that way. So that's all really cool. But how does Eleventy fit into all of that? I'm going to explain a little bit about why I like Eleventy. It's a static site generator, as I mentioned, built in JavaScript. And I think when you start Googling JavaScript static site generators, right, I think a few come to mind. There's one that's based off of a book that is really popular, Gatsby. That was a joke. I guess it failed. It's okay. Don't worry about it. There's some that leverage Vue to do these sorts of things, to build these sites. There's some that are kind of in this middle ground. Like you can have NestJS, which can be used to generate static, but can also be used to act as a server. But the point is, you have your pick of the litter when you're using static site generators, especially JavaScript ones. But I don't really hear people talking about Eleventy too often. Another popular static site generator, right, is Jekyll. That's really famous. A lot of you might have even used it yourselves. And Jekyll is famously used with the Obama campaign. Politics aside, they were able to leverage kind of these advantages that I talked about with these static sites, these index pages, to raise over $250 million for his campaign, which is pretty fascinating. Because when you're talking about faster page speed and quicker downloads, and you read all the reports, Amazon, Facebook, whatever, users leave after 10 milliseconds, whatever the case may be, that translates to money. So that you can build these sorts of static sites in a lot of different ways. And Eleventy was created to be the JavaScript alternative to Jekyll. So it uses a lot of the kind of logic and setup that Jekyll created to as its baseline. And why should you care about Eleventy? I'm glad you asked. It's 0 config by default, so that means that you could literally run right from your command line the tool, and then in the directory it will output HTML files without having a lot of setup. This is really nice sometimes if you want to just get something up and running, but that doesn't mean that it can't be extended upon and modified to your needs. We'll go a little bit about that, but that Eleventy works with your project's existing directory structure. So if you're using Rails, for example, and you need just certain things that are statically generated, you could build a process with Eleventy alongside of that, and really have no problem with either tool is interacting. Eleventy also works with multiple template engines. I'll list them out later, but there are 11 of them that it supports out of the box. You got everything from Pug to Nunjux to Liquid. So let's say you want to write some stuff in Markdown and you want to write some stuff with JavaScript template literals. Please do so. I wouldn't recommend it, but you can. But the idea is that it doesn't lock you into using any sort of language to generate your content. It also gives you access to the JavaScript ecosystem, which is pretty huge. And it's decoupled from any JavaScript frameworks and will stay that way. That's kind of its mission statement, is that unlike a Gatsby or I believe it's called GridSum, it doesn't force you to use React or Vue. You don't have to learn those technologies to use it. You can, of course, use those technologies with Eleventy if you'd like to. I mean, at that point, it's just simply importing them, but it doesn't start out that way. So it's really great for these kinds of maybe smaller tools, or if you don't think you might need the full power of a framework. So zero config. What do I mean by that? As I mentioned, right, you can run just the npx command at Eleventy, and if you're using npx, you don't even have to download any tools. It'll just download it for that one time that you're running the command, and this is really awesome if you just want to test it out, see what it is, and it'll search for the directory and outputs to an underscore site file. So you can just get up and running literally in 30 seconds on your computers. However, if you decide you want to start adding a little bit of configurations and playing around with different settings of Eleventy, you can create a .eleventy.js file in whatever your project's directory would be, and start kind of configuring to your heart's delight. That means you could go as simple as modifying the input and output folders, which maybe you want to do that. I have definitely done that for some projects. Or you can go a little bit more complicated and start really adding different features. This is actually the config file I currently have for an Eleventy site that I'm working on just for fun myself. You can see it kind of gets a little bit larger, and I'm at the top, I'm minifying the HTML, so that way it's a little bit smaller and quicker to get to the user. I'm sorting Pokemon by their Pokédex IDs, which is the nerdiest sentence I think I've ever said out loud. I'm adding a bunch of filters to Nunjux, so I'm extending on the Nunjux's default functionality pretty easily just by adding in different functions. I'm adding shortcodes, which are actually great because they bail out on me if I mess up my SVGs now, so I don't have to even worry about writing good SVGs. I've created a function that will just yell at me if I don't. And then just a few other things I'm doing, which aren't too important to this talk, but really the idea is just to show you this is that you can modify Eleventy to whatever your needs are. I mentioned multiple template engines. These are the ones out of the box that it supports. You got HTML, Markdown. You can use JavaScript, Liquid, Nunjux, Handlebars, Mustache, EJS, Haml, Pug, and JavaScript template literals. I'm a big fan of using Nunjux, and I think you'll find that a lot of the community has kind of centered around Nunjux. A lot of the community support for Eleventy has centered around Nunjux. It's really easy to extend. There's lots of tutorials that are just completely unrelated from Eleventy specific features that will help you get out of there, get up and running. But the main creator of Eleventy himself is actually recommends using Nunjux because those are the Nunjux and Liquid because those are the ones that they create the first features for to begin with. Well, thing that I think is very interesting is actually the ability to use JavaScript as a templating language. And that kind of looks a little different than what you might be expecting when you're talking about a static site generator. So you can kind of create these classes that would represent each of your pages and set up these data functions and these render functions, and it'll spit out based off whatever your data might be. Let's say in this example we've created a variable called meetup, Southeast Michigan JavaScript, and then you got your render function, which must be the same thing for each of the templates, and it would spit out, my favorite meetup is Southeast Michigan JavaScript. And this could be extended, right? You could do some API calls in here to asynchronously get data from an API, for example. So that way, if you wanted to get some updated data, you could do so, and Eleventy is smart enough to wait until that call has been successfully made to create the template. So you're not just putting out object, which is not helpful to anyone. One really neat thing about this is they are working on adding a feature for support for JSX, which I know a lot of people enjoy writing. They like that kind of way of putting the logic in your templates, and using different libraries, you can kind of get some stuff that if you squint at it looks a little similar to JSX. Where you can kind of import, and you can kind of imagine how you can take this. You can import different functions, different components, that you've constructed, and kind of put them in your templates like you would use JavaScript, React, and JSX, but without kind of the overhead of the client side rehydration, which is nice. You get access to, as I mentioned, you get access to NPM, and these are just some quick stats I pulled. Go, I think these are based off of popular static site generators in each of these languages. I think Go has Hugo, and that has about 20,000 modules that you can freely download. Ruby has Jekyll, as I mentioned, it has about 150, and then JavaScript JavaScript with Eleventy, is at over 1 million. So there's a decent amount of chance that if you want to add some functionality to your static site, maybe you want to render a timestamp differently, or you want to see if you want to add an S to page versus pages, something like that. There's a large chance that someone has built that functionality. Those are two pretty trivial kind of examples, but you can kind of see where it can go from there. And as I mentioned, it's kind of decoupled from any JavaScript framework. So by default, it ships 0 client-side JavaScript, which some people do like, some people don't like. That's kind of personal choice on you. I think it's good. It has kind of forced me, using Eleventy, to think about maybe different ways of getting data from different sources. So I'm not making API requests on the client side now. I'll make them as the templates are being generated, and then output the data that way. For my personal needs, that has actually worked out really well, because I don't need the latest amount of Twitter followers, for example, that I have. I think if I'm within a couple days of whenever I last ran the service, that's totally fine with me. Your needs might vary though, but if you're okay with maybe lagging a little bit behind, this can be a really fun thing to play around with. That's just some extra bits of fun things I want to show you with Eleventy. Here's actually a static Pokédex that I created to give you guys an example of what it looks like to have kind of a model-driven website, a data-driven website that is statically generated ahead of time. So if that link is completely live, you can go to it on your phone. This is a real thing. But you'll see if you end up using it, it's really fast, and there's no JavaScript that gets loaded except for just a little bit of the search functionality just to get it exactly. But if you were to hit this with your browser and have JavaScript turned off, this site would still completely load, no issues, and really shoot down a really minimal amount of kilobytes down the wire, which I think is really nice. And that's just static-pokédex.netlify.com. Here's another thing I really, kind of another trick I've been using in Eleventy is that I've been using it to inline my Sass, and that way you don't even have to worry about having Webpack or anything like that. You can just do it right in Eleventy's build process and use the build process of your templates as the build process. So you don't have to run a second one on top of that. Of course, your needs might vary. Maybe it doesn't make sense, and you do want an external CSS file. And there's plenty of cases where that matters, where that's actually what you want. But in these smaller sites that I've been working on, I don't need that, and actually stopping that external request is very helpful. And that actually kind of brings me to the end of the talk. It was pretty quick. Does anyone have any questions?
So you can rehydrate in JavaScript if you want to or need to?
Yeah, you can. You can absolutely. I mean, because it doesn't make any assumptions about what framework you're using or what framework you're not using or anything like that. You can totally put in the script tags and as necessary and build in your JavaScript like that. Maybe you want to load React on some pages and not others. You can totally build that functionality in yourself.